welcome back to Codeverse, where we make coding simple, fun, and powerful. Today, we're diving into one of the most important building blocks of Python, variables and data types. Think of variables as tiny labeled containers in your computer's memory. Each one stores a piece of information that you can use, change, or combine to make your programs come alive. And data types? Well, they define exactly what kind of information those containers can hold: numbers, text, true or false values, lists of items, and so much more. Whether you're brand new to Python or just brushing up on the basics, understanding variables and data types is like learning the alphabet before you write your first story. Without them, your code simply can't communicate. In this video, we'll explore how variables work, the rules for naming them, the different data types Python offers, and how to use them effectively in real-world coding. By the end, you'll be able to store any kind of data in Python and know exactly how to work with it like a pro. So, get ready, we're about to unlock the foundation of Python programming, step by step. In the last lesson, we talked about the big picture of variables and data types. Now, let's zoom in and really understand what a variable is, why it matters, and how you can use it like a pro. In Python, a variable is simply a name that points to a value stored in your computer's memory. You can think of it like a label on a box. The label is the variable's name, and the box holds the data. The beauty is, you can open the box, change what's inside, or even replace it with something completely different. When we say x equals 5 in Python, we're telling the computer, hey, store the number 5 somewhere in memory, and whenever I say x, I mean that number. And if later we do x equals 10, we're just swapping out the old value for a new one. Easy. Variables make your code flexible and reusable. Instead of hard-coding values everywhere, you can store them in variables and update them in just one place. Imagine having a game score, a username, or a configuration setting. With variables, you can manage all of that without hunting through your entire program. There are a few simple rules for naming variables. Names can have letters, numbers, and underscores, but can't start with a number. They can't be Python keywords like for, if, or while. And while you can use short names like x or y, descriptive names like score or user underscore name make your code much easier to read. The key takeaway: a variable is your way of giving data a name you can use again and again. It's one of the simplest, yet most powerful tools you'll use in Python, and it's the first step toward writing code that can actually do something dynamic. In the next part, we'll explore the many different kinds of data you can store in these variables, from numbers and text to lists and beyond. But for now, keep practicing creating and naming variables. Every program you write will rely on them, so the sooner you get comfortable, the faster you'll grow as a coder. Know what a variable is, it's time to talk about something that's surprisingly important: how you name them. In Python, variable names have to follow a few simple but strict rules. If you break these rules, your code won't even run. First, variable names can only contain letters, numbers, and underscores, but they can't start with a number. So, score 1 is fine, but 1 score will cause an error. Second, variable names can't use spaces. Instead, Python programmers use underscores to separate words, like user underscore name or total underscore price. Third, you can't use any of Python's reserved keywords as variable names. Words like for, if, while, and class already have special meaning in the language, so they're off limits. While Python is case-sensitive, meaning age, and age are 3 different variables, you should choose one style and stick with it for clarity. Most Python developers use lowercase with underscores, also known as snake underscore case. And here's a pro tip: even though you can use short names like x or y, descriptive names are way better for readability. Imagine coming back to your code 6 months later. Would you rather see x equals 500 or monthly underscore rent equals 500? Your future self will thank you. By following these naming rules and conventions, your code will not only work without errors but also be clean, clear, and easy to maintain. Think of it as giving your variables names that make sense, because variables are only useful if you can remember what they represent. Alright, now that we know how to name our variables, it's time to bring them to life by assigning them values. In Python, this is done with one of the simplest symbols you'll ever see, the single equals sign, equals. Now, I know what you might be thinking, equals sign. Isn't that for math? Well, not here. In Python, the equals sign doesn't mean this is equal to. It means, take what's on the right, and store it in the variable on the left. It's like giving a box a label, and then putting something inside it. For example, age equals 25. Here, we're saying, hey Python, create a container called age, and put the number 25 inside it. That's it, you've just stored a piece of data in memory that you can use later in your program. And the best part? You can store almost anything in a variable, numbers, text, true or false values, lists of items, and so much more. Some quick examples: name equals Alice, a string of text. Is underscore online equals true, a Boolean value. Price equals 19.99, a decimal number. Python is smart enough to figure out the type of data you've stored without you having to tell it. This is called dynamic typing. You just give it a value, and it does the rest. You can also change a variable's value at any time. If score equals 10 at the start of the game, you can later update it to score equals 20 when the player earns more points. It's just like swapping out the contents of your labeled box. Variables aren't just for storing data, they can be part of calculations, too. If you write total equals price quantity, Python will multiply those values and store the result in total. You can use variables in addition, subtraction, multiplication, division, and more, and Python will do the math for you. And it's not just numbers, you can combine text as well. If you have first underscore name equals Alice and last underscore name equals Smith, you can join them with full underscore name equals first underscore name plus last underscore name. This is called string concatenation, basically sticking pieces of text together. When you assign a value, Python creates that variable in memory and keeps it there until it's no longer needed. If you reassign it, Python updates the value in place. So, in short, assigning values is one of the most common actions you'll do in coding. It's how you store, update, and work with information, and once you get comfortable with it, you'll start to feel like you're in full control of your code's memory. When you store something in a variable, Python always needs to know what kind of thing it's dealing with. That's where data types come in. Think of a data type as a label that tells Python, hey, this is a number, or this is a piece of text, or this is a list of items. Different data types behave differently. You can add numbers together, but adding two pieces of text does something else entirely, it joins them together. Some of the most common Python data types are numbers like int, float, and complex. Text with the str type. True/false values using bool. Collections like list, tuple, and dict. Python is a dynamically typed language. You don't have to tell it in advance what type of variable will hold. It figures that out automatically from the value you assign. For example, age equals 30. Python knows it's an integer. Price equals 19.99. That's a floating point number. Name equals Alice. That's a string. Why does this matter? Because knowing the data type tells Python what actions are allowed. You can multiply numbers, but trying to multiply a string by a string will give you an error. You can multiply a string by a number though, and Python will repeat it. *3, ha ha ha. As your programs grow, understanding data types helps you avoid bugs, write cleaner code, and use Python's features to their fullest. By the end of this section, you'll be able to identify the type of any value, use the right data type for the job, and even change between types when you need to. So, let's dive in and explore the world of Python data types step by step. Alright, now that we know what data types are, let's start with some of the most common ones you'll use in Python, numeric types. Python has three main numeric types: int for whole numbers, like 5, 0, or -42. Float for decimal numbers, like 3.14 or -0.001. Complex for complex numbers, like 2 plus 3j. An integer, int, is exactly what it sounds like, a number without any decimal point. Perfect for counting things, keeping score, or working with values that are always whole. A float is a number that does have a decimal point. You'll use floats for precise measurements, money, though with care, or anything involving fractions. And a complex number, well, unless you're doing advanced math, physics, or engineering, you might not see these often. But Python supports them out of the box, with a real and an imaginary part. Here's the cool thing, Python automatically decides which numeric type to use based on what you type. If you write 10, it's an integer. If you write 10.0, it's a float. And if you write 2 plus 3j, it's complex. You can also convert between numeric types easily. Want to turn an integer into a float? Just use float, 5, and you'll get 5.0. Need to turn a float into an integer? Use int, 3.99, just remember, it truncates the decimal, it doesn't round. And because Python is super flexible, you can mix numeric types in math operations, though the result will often be a float if one of the numbers is a float. By the end of this section, you'll be able to confidently store, convert, and work with all kinds of numbers in Python, from simple counters to complex scientific calculations. Strings in Python, or str for short, are one of the most common and powerful data types you'll use every single day. A string is simply a sequence of characters, letters, numbers, symbols, spaces, anything you can type on a keyboard. If you've ever written a sentence, typed your name, or even just pressed a key, congratulations, you've worked with string-like data. In Python, strings are created by surrounding text with quotes. Single quotes like hello, double quotes like hello, and even triple quotes for longer, multi-line text. The computer doesn't care which type of quotes you use, but it does care that you open and close them properly. If you forget one, Python will get confused and throw an error. Strings are more than just words, they're a way to store and work with information that isn't purely numeric. Usernames, email addresses, error messages, book titles, chat messages, even emoji, all are strings in Python. One of the best things about strings is that you can combine them. This is called concatenation. For example, hello plus world gives you hello world. It's like snapping Lego bricks together, one piece of text after another. You can also repeat strings with the multiplication operator, hi. Asterisk 3 gives hi. 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 Yes, Python is happy to make echoes for you. Strings also have indexes, which means every character has a position number, starting from 0. Python 0 is P, Python 1 is Y, and so on. You can even slice strings to get parts of them, like cutting a cake, Python 0:3 gives pyt. And don't forget, strings come with a toolbox of built-in methods. You can make them uppercase with .upper, lowercase with .lower, count characters, replace words, and check if something's inside. These methods save tons of time when you're cleaning or formatting text. So why do strings matter so much? Because text is everywhere in the digital world. Anytime you display output, take input, or send information across a network, there's a good chance you're dealing with strings. Master them, and you unlock a huge part of programming's power. By the end of this section, you'll know how to create strings, join them, slice them, and transform them, giving you the ability to communicate clearly with your program and your users. Now let's talk about one of the smallest, but most powerful, data types in Python, the Boolean, or bool for short. Booleans can only hold two possible values, true or false, and yes, they must be written with a capital T or F. Think of Booleans like a light switch, it's either on, true, or off, false. They're incredibly important because they allow your programs to make decisions. For example, is the user logged in? True or false? Has the game ended? True or false? Is the temperature greater than 30 degrees? True or false. You'll often see booleans as the result of a comparison, 5 greater than 3 true. 10 equals 5 false. Cat not equals to dog true. Whenever Python evaluates a condition, it gives you back a Boolean value. And here's a cool thing, Booleans are actually a subtype of integers in Python. That means true behaves like 1 and false behaves like 0. So you can even do math like, true plus true 2. False plus 5. But in practice, you'll mostly use them for controlling the flow of your program, deciding what code should run and what shouldn't. Mastering Booleans means you can start building programs that react, adapt, and make smart choices, and that's when coding starts to feel truly powerful. When we talk about sequence types in Python, we're talking about ordered collections, structures that store multiple items in a specific order. Each item has a position, called an index, starting from 0. Lists. A list is like a flexible box, you can add, remove, or change its contents anytime you want. It's written with square brackets, fruits equals, apple, banana, cherry. Lists are mutable, meaning they can change after creation. You can append items, delete items, or modify them directly. Tuples. A tuple is like a sealed box, once you put items in, you can't change them. It's written with parentheses, coordinates equals, 10, 20. Tuples are immutable, so they're great for data you want to keep safe from accidental changes. Ranges. A range represents a sequence of numbers, usually used in loops. For I in range, 5 print, I. This produces numbers from 0 to 4. You can set a start, stop, and even a step value. Indexing and slicing. You can access items in lists or tuples by their index, fruits, 0, apple. And you can grab slices, subsets, of sequences, fruits, 1:3, banana, cherry. Common uses. Lists, storing changing data like scores, user input, or to-do items. Tuples, fixed data like coordinates, RGB color values. Ranges, counting, iterating over loops efficiently. Tip, use lists when flexibility is needed, tuples when data must be constant, and ranges for efficient number sequences without storing them all in memory. A dictionary in Python is like a real-life dictionary. Instead of words and definitions, it stores key-value pairs. The key is like a label, and the value is the information linked to that label. Structure. Dictionaries are created using curly braces, with key-value pairs separated by a colon, person equals. Name, Alice, age, 25, city, New York. Here, name, age, and city are keys, and Alice, 25, and New York are their values. Key points. Keys must be unique, no duplicates allowed. Keys must be immutable types, like strings, numbers, or tuples. Values can be any type, numbers, strings, lists, even other dictionaries. Accessing values. You can get a value by using its key, person, name, Alice. Modifying dictionaries. You can add or change a key-value pair, person, age, equals 26. Person, job, equals engineer. You can also remove items with del or .pop. Iterating through dictionaries. Loop over keys, for key in person, loop over values, for value in person. Values, loop over both, for key, value in person. Items, real-world uses. Storing user profiles. Configuration settings. Mapping IDs to data. Summary. Dictionaries give you fast lookups, clear key-value relationships, and flexible value types, making them one of the most powerful data structures in Python. Let's talk about one of Python's most interesting and underrated data types, sets. If lists are like boxes that can hold anything, sets are like magical boxes that only keep unique items. A set in Python is an unordered collection of unique elements. That means, no duplicates allowed. If you try to add the same thing twice, Python just ignores it. No guaranteed order, the items don't remember the position you added them in. You create a set using curly braces, or the set function. For example, fruits equals apple, banana, orange. Now fruits contains 3 items, and even if you add apple again, the set won't change. Sets are perfect when you want to store things without worrying about duplicates, like unique usernames, tags, or IDs. They also have powerful math-like operations, union, combine 2 sets into one, without duplicates. Intersection, find common elements between 2 sets. Difference, find what's in one set but not in the other. It's like comparing lists with superpowers. Then there's frozenset, the frozen cousin of the set. A frozenset is just like a set, but immutable. Once you create it, you can't add or remove items. This makes it hashable, so you can even use it as a key in a dictionary. Think of it this way, set equals reusable container, you can add, remove items anytime. Frozenset equals sealed container, contents are locked forever. By mastering sets and frozen sets, you'll have tools for fast membership checks, powerful comparisons, and elegant solutions for problems involving unique data. It's one of those small Python features that can save you a lot of coding headaches. Type conversion, also called casting, is the process of changing a value from one data type to another in Python. Why is this important? Because sometimes the data you have is in the wrong type for the task you're trying to do. If you want to add numbers but your data is in strings, or you want to combine text but you have integers, Python will throw an error unless you convert them. There are 2 main types of type conversion in Python: implicit type conversion, also called type coercion. Here, Python automatically changes the data type for you when it's safe to do so. For example, if you add an integer and a float, Python will convert the integer to a float so the operation works without losing precision. Result equals 5 plus 2.55 becomes 5.0 automatically. Print, result, 7.5. This is convenient because you don't have to think about it, but it only happens in certain safe cases. Explicit type conversion, where you, the programmer, deliberately change the type using built-in functions like int, convert to integer. Float, convert to floating point number. str, convert to string. Bool, convert to boolean. List, convert to list. Tuple, convert to tuple. Set, convert to set. Example, age_str equals 25. Age_number equals int, age_str, string int. Print, age_number plus 5, 30. Important things to remember: not every conversion is possible. Trying to convert hello into an integer will cause a value error. Converting a float to an int will truncate the decimal, not round it. Int, 5.95. Booleans convert to numbers where true becomes 1 and false becomes 0. Int, true, 1. Real-world use cases: reading user input from input, always gives a string, you'll often need to convert it to numbers. When working with APIs or files, data might arrive as strings and require casting before processing. Preparing data for mathematical operations, sorting, or joining strings. By mastering type conversion, you'll avoid many common errors and gain flexibility in your code, making it easy to handle data in whatever form it comes. Imagine you're in a massive library, thousands of books everywhere. Before you can read or use a book, you need to know its category: fiction, science, history. In Python, it's the same with variables. Before you work with data, sometimes you need to know its type. That's where Python's built-in type function comes in. Just pass a variable or value to type, and it tells you exactly what kind of data you're dealing with. Example, age equals 25. Print, type, age. This will output, class int. Meaning age is an integer. It works for any data type: strings, floats, booleans, lists, dictionaries, even your own custom classes. Why is this important? Because in programming, the way you treat a number is different from the way you treat text. If you don't know the type, you might try an operation that doesn't make sense, like adding a string to a number. Here's another example: name equals Codeverse. Print, type, name. Output, class str. This tells you name is a string, perfect for text operations. You can even use type, when debugging. It's a quick way to check if your variables are holding the kind of data you expect. So, remember, when in doubt, ask Python what type you're dealing with. Just like checking a book's category before reading, knowing your variable's type keeps your code running smoothly. Alright, coder, it's time to put theory into practice. We've covered variables, naming rules, assigning values, and the different data types Python offers. Now, let's see them all working together in a single, real-life example. Imagine we're creating a profile for a new user in a game. Step 1, let's store the player's information. We'll create, username string, player_1. Age integer, 21. Score float, 99.5. Premium_user boolean, true. Favorite_colors list, blue, green, red. Settings dictionary, volume, 75, difficulty, medium, control, keyboard. Step 2, we'll display this information with print, so the player can see their profile in a friendly format. Step 3, we'll use Python's built-in type function to confirm the data type of each variable, showing that Python knows exactly what each piece of information is. Here's the complete code: username equals player_1. Age equals 21. Score equals 99.5. Premium_user equals true. Favorite_colors equals blue, green, red. Settings equals volume, 75, difficulty, medium, control, keyboard. Print, player profile. Print, username, username. Print, age, age. Print, score, score. Print, premium user, premium_user. Print, favorite colors, favorite_colors. Print, settings, settings. Print, data types. Print, username, type, username. Print, age, type, age. Print, score, type, score. Print, premium_user, type, premium_user. Print, favorite_colors, type, favorite_colors. Print, settings, type, settings. When we run this, the output first shows the profile information exactly as we stored it, and then the types of each variable: string, integer, float, boolean, list, and dictionary. This example shows how variables are the building blocks of every program, and how data types give them meaning. Now that you've seen it in action, you're ready to mix and match variables and data types in your own projects. Alright coder, time for a quick mini quiz. I'll ask you a question, then give you the answer right after. No suspense, no pressure. Question 1. Which of these is a valid Python variable name? A. toScore. B. Score_2. C. Score2. Answer: Score_2, because variable names can't start with a number and can't contain hyphens. Question 2. If I write x equals 3.14. What is the data type of x? Answer: float, since 3.14 is a decimal number. Question 3. True or false? In Python, variable names are case-sensitive. Answer: true, name and name are two different variables. Question 4. Which data type would you use to store a list of your 3 favorite colors? Answer: list, perfect for storing multiple values in one variable. Question 5. What function in Python can you use to check the type of a variable? Answer: type, it tells you exactly what kind of data a variable holds. You nailed it. Even if you got 1 or 2 wrong, you're still making solid progress. Now, let's roll into the final challenge where we put all this knowledge into action. Alright, this is it. The grand finale of our variables and data types journey. You've learned the rules, mastered the types, and practiced with examples. Now, your mission, should you choose to accept it, is to build your own Python user profile generator. Here's your challenge. 1. Create a program that stores at least one variable of every data type we covered: string, integer, float, Boolean, list, tuple, dictionary, set or frozen set. 2. Assign meaningful variable names following the rules we learned. No random x or temp here, make them descriptive. 3. Print out your data in a clean, user-friendly format, almost like a profile page. 4. Then, for each variable, use type to display its data type. 5. Bonus points, try using casting to change the type of one variable and print the result. Pro tip: organize your code so it's easy to read. Maybe even add little section titles in your print statements. When you're done, run your program and check, does it display everything clearly? Does type confirm you've used all the types? Remember, this isn't just about passing the challenge, it's about proving to yourself that you can take individual concepts and weave them into a complete, working program. Alright Pythonista, it's time. Fire up your editor, and make your variables come alive. Congratulations, coder. You've just completed one of the most important foundations in Python: variables and data types. You now know how to store information, choose the right type for the job, and check and convert between types like a pro. With this knowledge, you can build programs that think, remember, and communicate with precision. But this is just the beginning. Next up, we'll take your Python skills to the next level by making your programs interactive, teaching them to get input from the user and display output in creative ways. This means you'll be able to build programs that talk back, calculators that take your numbers, games that ask for your name, and apps that respond to your choices. So keep your code editor open, because we're about to make Python not just smart, but talkative. I'll see you in the next episode: User Input and Output in Python.